Picture a swamp. Warm water. Total silence. Then the water moves. Not like a fish, like something rolling underneath it. What if I told you there was once a snake so big it could swallow a crocodile whole and walk away unhurt? No CGI. A real animal that actually slithered across this planet, breathing real air, hunting real prey in a real river that still exists today. This is not a story about dinosaurs. This is something that came after them. Something even stranger because it proves the age of giants didn't end when the dinosaurs did. By the end of this video, you'll understand why scientists who found its bones didn't believe what they were looking at. At first, they thought it belonged to a crocodile. They were wrong. And what it actually was turned out to be far more unsettling. Its name is Titanoboa. And the name fits, because Titan is exactly the right word. This wasn't just a big snake. It was, as far as we know, the largest snake to ever exist on Earth. Not the largest in a single fossil bed, not the largest in one region, but the largest snake science has ever confirmed. Bigger than any anaconda. Bigger than any python. Bigger, in fact, than almost anything alive on land today that isn't an elephant. It lived millions of years before a single human being walked the planet, in a world so hot and so wet that literally resembles the Earth we know now. By the end of this video, you'll know exactly how big it really was, how it hunted, why it grew so enormous, what scientists recently discovered about its skull that changed the story, despite how terrifying it sounds. Something like it could never survive on Earth today. But first, we need to go back. Back to a world that doesn't look like our planet at all. 60 million years ago, the dinosaurs were already gone, wiped out roughly 5 to 6 million years earlier in one of the most violent extinction events in Earth's history. But here's the part most people don't expect. The world that came after the dinosaurs may have been even more extreme in some ways. This period is called the Paleocene, and it was a planet recovering, rebuilding, and experimenting with new giants. Earth was hotter. Much hotter. Average temperature near the equator were several degrees warmer than they are today. Why? And some regions stayed warm and humid all year round, with no real winter at all. The rainforests weren't just big, they were endless, thick, swampy, wide, dripping with heat, stretching across what is now northern South America for thousands of miles with almost no break. Fossilized pollen and leaves found in this region show a lowland tropical forest strikingly similar to today's Amazon, just hotter, array, and emptier of mammals. And in that heat, something strange happened to the animals living there. Mammals at this point in history were still small, mostly rodent-sized or smaller. The dinosaurs that once ruled the land were gone. That left a gap at the top of the food chain, and reptiles rushed in to fill it. Crocodile relatives the size of small boats patrolled the rivers. Turtles grew large enough that a grown man could sit comfortably inside their shell. One species found in this same region, Carbonemys, had a shell over 5.5 feet long, the size of a small dining table. This wasn't a freak accident. Heat, combined with endless food and almost no competition, is a recipe nature has used again and again throughout its history to build giants. It happened with dinosaurs, it happened with prehistoric insects, and now in this strange, steaming aftermath of extinction. It was about to happen with a snake. Somewhere in that river system, coiled and waiting, something was about to become the biggest reptile predator the world had ever produced. and for nearly 5 million years, it would rule completely challenged. For decades, nobody knew Titanoboa existed. His bones were sitting underground the entire time, completely undisturbed in northern Colombia, in a region called La Guajira. The location was a massive open-pit coal mine called Cerrejón, one of the largest coal mines in the world. Coal mining strips away enormous amounts of rock and sediment, which, by sheer coincidence, exposed layers of earth that hadn't seen sunlight in nearly 60 million years. In the early 2000s, a team of paleontologists began surveying the mine for fossils dating to the period right after the dinosaurs vanished. The team included Jonathan Bloch from the University of Florida, Carlos Jaramillo from the Smithsonian Tropical Research Institute, and a young researcher named Jason Head, who would go on to lead much of the analysis. They were hoping to find ancient turtles and crocodiles, animals already known from similar rock layers elsewhere. What they found instead made them stop in their tracks. A single vertebra, one bone from the spine, was so large that researchers initially assumed it had to belong to a crocodile. Crocodile vertebrae and snake vertebrae look different once you know what to compare, but the size alone was enough to make them doubt themselves at first. It didn't take long to settle the question. When they compared the bone's shape and structure to known snake skeletons, the features were unmistakable. The shape of the joints, the curve of the bone, the way it would have connected to its neighbors. This was a snake. Just an impossibly large one. Over several expeditions between 2007 and 2009, the team recovered more than 100 vertebrae and several ribs, eventually representing at least 28 individual snakes. This wasn't a one-off freak skeleton. It was an entire population of giants. In 2009, the discovery was formally announced in the scientific journal Nature, and the species was officially named Titanoboa cerrejonensis, is Titanic boa from Cerrejón. It instantly became one of the most talked about fossil discoveries of the decade, making headlines around the world almost overnight. But the story of its discovery wasn't finished. Years later, researchers uncovered something even more revealing buried in the same rock. Pieces of an actual Titanoboa skull, and what that skull showed would quietly rewrite part of the story science had already told about this animal. We'll come back to that. Let's actually picture this thing, because numbers alone don't do it justice. Scientists can't simply measure a complete, perfectly preserved skeleton, because no full skeleton of Titanoboa has ever been found. Only vertebrae, ribs, and skull fragments. So researchers used a clever method. They compared the width of Titanoboa's vertebrae to the vertebrae of 36 living snake species, where the relationship between bone size and total body length and weight is already well understood. Using that math, the team estimated Titanoboa reached lengths of around 12 to 15 meters, somewhere between 40 and 50 feet long, depending on the individual and the specific calculation used. To put that into perspective, that's longer than a city bus. It's longer than 2 cars parked end to end with room to spare. A modern green anaconda, already the heaviest snake alive today, has a confirmed maximum length of just over 5 meters. Even taking the most generous modern records, Titanoboa was still more than double that length. And it wasn't just long, it was thick. Estimates suggest its body at the widest point may have approached a meter in diameter. That's roughly the width of a large oil barrel. Except this one could move, hunt, and constrict. its estimated weight comes out to somewhere between 1,100 and nearly 1,300 kilograms, over a metric ton, in some estimates close to 2,500 pounds. That's heavier than a small car, and in the same range as a fully grown adult hippopotamus. A human standing next to it would barely reach its midsection. Not its head, its side. If it had reared up even slightly, the way some large constrictors do when striking, it could have looked a grown adult directly in the eyes without lifting its body very far off the ground at all. This wasn't an animal you'd spot and run from. By the time you saw it, if you saw it at all, it may have already chosen whether you were worth the effort. So how does an animal this enormous actually catch prey? Titanoboa almost certainly hunted the way modern boas and anacondas do. Through ambush, not pursuit. Speed and chasing waste enormous amounts of energy. Why, and a body that size doesn't need to chase anything. It would lie motionless, mostly submerged in slow-moving rivers and swamps, using the murky water to hide its enormous body completely. Many of its modern relatives, like green anacondas, can stay almost entirely still for hours, with only their eyes and nostrils breaking the surface. When prey came close, a fish, a turtle, even a smaller crocodile relative, it struck with sudden, explosive speed, using the same lunging mechanics seen in living boas, just scaled up to a body the size of a city bus. Then came the part that made it so deadly: constriction. Titanoboa would wrap its massive body around its prey and squeeze, not to crush bones into pieces, but to stop the heart and lungs. Recent research on modern boas has shown constriction doesn't just suffocate prey. It can cut off blood flow so efficiently that the animal loses consciousness within seconds, long before suffocation alone would even take effect. And with a body that size, the force involved would have been immense. Based on what's known about the muscle structure of large modern boids, some researchers have suggested the pressure Titanoboa could generate may have been many times greater than anything a human body could survive. For years, scientists assumed this meant even animals we think of as untouchable, like crocodiles, were not safe. Fossil evidence from the same Cerrejón site shows multiple species of crocodile relatives living alongside Titanoboa, including one called Cerrejón, meaning these two giants almost certainly crossed paths in the same rivers, possibly even competing for the same hunting grounds. But here's the twist that came later. When researchers eventually recovered pieces of Titanoboa's actual skull, the shape of the jaw and teeth told a slightly different story than expected. The teeth were long, thin, and curved, perfectly built for gripping slippery prey like fish, rather than the broader, more reinforced bite structure you might expect from an animal regularly tackling armored crocodilians. This doesn't mean Titanoboa never ate crocodiles. Large boas today are opportunistic, and something this size would have eaten almost anything it could overpower. But the skull suggests its everyday diet may have leaned heavily toward the enormous fish that also lived in these rivers, meaning the image of Titanoboa locked in constant battle with crocodiles might be more occasional than routine. Either way, in the water, Titanoboa had every advantage. It was a powerful swimmer, and in its world, there was very little reason to fear anything else. Here's where the science gets genuinely fascinating, because Titanoboa's size wasn't random. It was a side effect of the exact world it was born into. Snakes are cold-blooded, also called ectotherms. Their body temperature depends almost entirely on their environment. not on internal heat generation the way mammals work. A cold-blooded animal in a cooler climate has to spend energy just staying warm enough to function. That means, in a hotter climate, cold-blooded animal can grow faster, process more energy for actual growth instead of basic survival, and ultimately reach much larger body sizes over their lifetime. Researchers used this exact relationship to do something remarkable. They worked backward from Titanoboa's size to estimate how hot the ancient tropics actually were. Since the maximum size of cold-blooded animals is closely tied to ambient temperature, an animal this large could only exist if the climate around it was warm enough to support it. Their conclusion, published alongside the original discovery, why, was striking. Equatorial temperature during this period may have averaged somewhere around 30 to 34 degrees Celsius, even warmer than some climate models for that era had predicted. In other words, Titanoboa's own body became a kind of ancient thermometer, helping scientists understand the Paleocene climate more accurately than rock data alone could. This is what's known scientifically as the thermal hypothesis, and it remains one of the leading accepted explanations for Titanoboa's size. It's worth being clear that this is a well-supported scientific theory, backed by measurable biological patterns seen in living reptiles today, not a guess pulled from nowhere. On top of the heat, there was something else fueling its growth: opportunity. With the dinosaurs gone and large mammals not yet evolved, the very top of the food chain was essentially empty. Massive turtles and large fish provided abundant food, and there was no equally massive predator around to challenge a growing snake for that role. With heat fueling its metabolism, food readily available, and no real competition at the top, Titanoboa had every evolutionary advantage pushing it toward enormous size, and almost nothing pushing back. In short, extreme heat, abundant prey, wawaias, and an empty throne at the top of the food chain. That specific narrow combination of conditions is what built a monster. And it's exactly why a monster like this hasn't appeared again since. So here's the real question. Could a snake like this exist right now, W, somewhere deep in a modern rainforest? The honest scientific answer is no, and the reasons are bigger than people expect. First, temperature. Today's tropical climates, while hot, are simply not as consistently extreme as the Paleocene world Titanoboa depended on. Even small differences in average temperature have a major effect on how large a cold-blooded animal's body can ultimately grow. Without that extra warmth, a cold-blooded animal this size would struggle to fuel its own metabolism efficiently enough to reach, let alone maintain, that kind of body mass. Second, habitat. The massive unbroken swamp ecosystems Titanoboa depended on no longer exist in quite the same way. Modern rivers and wetlands, even large ones, are more fragmented, more seasonal, and shaped by millions of years of additional geological and climate change. Third, competition and food supply. The giant turtles, and many of the crocodile relatives it once shared rivers with, are extinct. Modern ecosystems are dominated by a completely different set of species, shaped by tens of millions of years of separate evolution, including large modern mammals that simply didn't exist yet in Titanoboa's time. And finally, humans. Even if somehow the right combination of heat, habitat, and food existed again somewhere remote, it's difficult to imagine an animal that size going unnoticed, undisturbed, and unhunted in a world covered by human settlements, roads, and satellite monitoring. Titanoboa wasn't defeated by being weak, slow, or poorly adapted. It belonged to a specific, narrow moment in Earth's history, a brief multi-million-year window after the dinosaurs and before large mammals. And when that moment ended, so did the conditions that made an animal like it possible. So after everything, the fossils, the size, the heat, the hunting, the skull that quietly rewrote part of the story, here's the thought worth sitting with. Nature didn't need horror movies to invent something monstrous. It already had, millions of years before anyone existed to be afraid of it. Long before anyone wrote a single monster story, why aerial snake, longer than a city bus, was quietly ruling the rivers of what is now Colombia, completely unchallenged for nearly 5 million years. And here's the fact to leave you with. The same fossils that revealed this giant snake also helped scientists understand just how hot our planet's distant past really was, turning one ancient predator's bones into a kind of climate record buried in stone. Titanoboa wasn't just the largest snake to ever live. It was a message, frozen in rock for 60 million years, waiting patiently underground until a coal mine in Colombia accidentally dug deep enough to finally let it tell its story.